Okay, we're going to look at a couple applications of applying the distance formula. The first one we get the opportunity to do is a right triangle. So, if I want to apply the distance formula to a right triangle, when you're talking about distance, you're talking about the sides of a right triangle. So when we're looking at these problems, if we apply the distance formula to a right triangle, that means I'm looking at this. So let's assume that's a right triangle and that's a right angle. It's a little off there, but we're close. So if I have this right triangle, I want to look at the sides, and I'm going to label them A, B, and C. Now, think back to geometry. What is a formula that we know that can be applied to the sides of a right triangle? Yeah, the Pythagorean theorem. So, with our Pythagorean theorem, we know that the formula is a squared plus b squared is equal to c squared. So that's the kicker. The distance of the side A and the distance of side B is equal to the distance of side C. Now, you know A and B can be interchangeable. They're the legs, is what they're called, or legs. C, however, has a fancy pants name called a hypotenuse. And a hypotenuse always happens across from the right angle. So C is always going to be the longest side because that is across from the biggest angle in our triangle. So A squared plus B squared doesn't matter, but C squared always has to be the longest side when you're looking at these problems. Okay, let's try one. Alright, so for this one, we want to know if the points M, N, and Q are the vertices of a right triangle. In order to determine if they're vertices of a right triangle, we got to find the distance between each one of those because that's going to give us our side length. And that's how we can use our Pythagorean theorem. So, let's do this thing. We have side length MN that we get to find. We get side length NQ that we get to find. And last but certainly not least, we get side length MQ that we get to find. Now, we've got 2 points. We've got a distance formula. Let's do this thing. And honestly, the whole purpose of this problem is just, hey, let's find a different way that we can apply the distance formula that's not just so rote, hey, plug and chug these 2 points. So, we're spicing it up, and this is how we spice it up. So, let's do it right now. If I take M and N, we're going to take the square root of -2 minus 12, that quantity squared, plus 5 minus 3, that squared, and break that down. -2 minus 12 is -14, so I'm going to write that in there. So -14 squared plus a 5 minus 3 is a 2 squared. So if I break that down, I'm going to bring it down here. That's going to equal the square root of 196. Notice it's positive because the negative is squared, plus 4. So you get the square root of 200. You can leave it as a square root of 200 if you want because the Pythagorean theorem squares that. So the square and the square root will cancel out. However, if you get excited about it, which I know you do, then you can break that down to be 10 square roots of 2. It's your prerogative if you want to leave it as a root or if you break it down. I don't care. 100% up to you. Okay, let's do more. So let's do N and Q. We end up with the square root of 12 minus 10 squared plus a 3. Now, minus a -11 is going to be the same thing as plus 11. I'm cool with you going straight there. So this is actually the square root of 2 squared plus a 14 squared. And we already know that because we're awesome. So we have the square root of 4 plus 196. Basically, I think we're looking at an isosceles triangle here, people, because those sides are the same. Super cool. All right, let's do this thing. So if I have M and Q is our last but certainly not least, I have -2 minus a 10 squared And again, I just like to go left to right. It's your prerogative what you want to do. 5, and it's minus a negative 11 again, so I'm going to put plus 11 squared, and then we can simplify that. So negative 2 minus 10 is a negative 12 squared. 5 plus 11 is a 16 squared. So let's work this out. Negative 12 squared is going to end up being a positive 144. 16 squared is 256. So if I get 144 plus 256 is 400, that can break down to a 20. Awesome. Cool. Now, I've done all of my work and I know my different side lengths that I have going for me here. I've got 10 square roots of 2, 10 square roots of 2, and 20. So when you plug that into your Pythagorean theorem, a squared plus b squared equals c squared, the small sides are the smaller numbers. We have 10 square roots of 2 squared plus 10 square roots of 2 squared is equal to 20 squared. Now I'm running out of room here, but I think we can see what's happening here. 10 square roots of 2 squared is going to be 200. 10 square roots of 2 is 200. Oh my, and 20 squared is 400. So what's 200 plus 200? Aha! Does 400 equal 400? All day long, baby. So if we're looking at this problem, the whole question comes down to this one word. Yes. Da-da-da-da-da-da. If I have this problem, it's saying, are these vertices of a right triangle? Yes, they are. And you have to show your work. You have to show all of this work because honestly, the whole purpose of the problem is to do these 3 parts. The bottom part is just a nice quick, you do still have to show it because that's what's actually answering your question, but it is just a nice quick, hey, is this legit? Yes, yes it is. If you had 2 numbers that were not equal, then the answer to that question would be no. So it's just a way to apply the distance formula. So as long as you're working through the distance problem, that's the main thing I want to make sure I'm seeing. And then the bottom purple part here just answers your question, which is the super easy part. Cool, let's do more. All right, our next example that we're going to look at is applying the distance formula to collinear points. Now, remember in mathematics, pretty much what it says is what you're doing. So if I want to apply the distance formula to collinear points, then I want to find 2 points that are, hey, collinear. Collinear meaning on the same line. So if I have I said 2, I meant 3. B, and C. So determine if these points are on the same line. I have segment A to B, and I have segment B to C. If you add those 2 small segments together, then we get the whole shebang. So AB plus BC is going to equal AC. So the 2 small inside ones is going to equal the big long one is basically what we're looking at there. Okay, let's do this thing. All right, let's answer this question. Are the points P, Q, and R collinear? Now here's the first thing that we would need to do. Whenever you set these points up, and this problem already has it done for me, so that's pretty much amazing. Whenever you're looking at these problems, you want to set up your values where X is numeric. So the smallest X value first, and then you work it down to the last. So like -1 becomes before 2, comes before 4. So that's already in order. So you want to put them in order with the X coordinate. Done. So with our problem here, I've got to find these distances. So I want to find PQ. I want to find line segment QR. And I want to find the last line segment of PR. Now, when you're looking at this, as soon as you put these in order, then you know that PQ plus QR is supposed to equal PR. That's our formula. So whatever values we get there, when you put them in that X order, that's how you know your formula that you have set up. Sweet. Okay, let's do it right now. I have the square root of -1 minus 2 squared plus 5, and I'm going to add 4 because it's minus a negative, which actually gives me a -3 squared plus a 9 squared. That's a 9. Okay, so this is going to equal 9 plus 81. So if we break that down, I actually end up with the square root of 90. So for this problem, we are going to break it into 3 square roots of 10 here because you want to break it down because you're going to be adding. Okay, let's do the next one. Let me change my color up here. Okay, so I have QR is going to be the square root of 2 minus 4 squared plus a -4 plus 10. Again, I'm subtracting a negative, so you can add that. That's a square up there. Is equal to the square root of -2 squared plus a 6 squared. So I get the square root of 4 plus 36, and that's going to be the square root of 40. So 2 square roots of 10 is our answer for that one. And last but certainly not least, let's do PR. And we get -1 minus 4 squared plus 5. Again, I'm subtracting a negative, so I'm going to add 10 squared. And this is going to give me a -5 squared plus a 15 squared. That's the same thing as 25 plus, and then the square root of 15 is 225. So I'm looking at the square root of 250. So you can break that down and get 5 square roots of 10. So this now gives me, if I have PQ plus QR is supposed to equal PR. So PQ in this instance is 3 square roots of 10. QR is 2 square roots of 10, and that is supposed to equal PR, which is 5 square roots of 10. Now go back and think about what you know about radicals. You can add and subtract radicals as long as you have the exact same thing under a radical. Check it. We have the square root of 10. That's awesome. So 3 plus 2 is 5 square roots of 10 equals 5 square roots of 10. All day long, baby. So what's our answer to this? Are these points collinear? Heck yes, they are. They're totally collinear. Now, what would give this an answer of no? If they're not. And the beauty of this kind of problem, whenever you go through and you're simplifying your radicals at your different line segments, the 3 square roots of 10 up here may be something, and then you could get something freaky deaky like, oh, I don't know, for the next problem, you would get like 2 square roots of 15. I mean, things that you know are not going to add together. Now, the answer or the question people always ask is, do I got to keep going? Yes, because just like this problem, the whole purpose is, can you find the distance? So practice using the distance for these different problems. Now, this collinear problem and that Pythag problem are long problems, so because of that, you are only going to have one of those on your test. I'm obviously not going to tell you which one. I want you to practice them both, but you're only going to have one of them, so you're not going to have to do a whole bunch of these types of problems because they just take so long to do. Cool.